In this tutorial, I'm going to show you how to write an equation of a line given 2 points on the line, as well as writing an equation of a line given a graph. Before we jump into that though, let's review how to calculate a slope of a line when given 2 points. So if you happen to look over here, we have 2 points and the equations are to find the slope of the line. It goes through those points. So first, let's remind ourselves of the formula that we use to calculate slope when you have 2 points. And that formula is m equals y2 minus y1 over x2 minus x1. And when we look at our points, we want to label them. Always label your points. It makes everything easier and it helps eliminate little mistakes. So we label it x1, y1, x2, y2. And if you forget how they're labeled, it shows you on your reference sheet, as well as this formula. So now it's a matter of plugging and chugging. Cookbook City from here. So we get m equals y2 is 6 minus y1 is 2 over x2 is 7 minus x1 is 15. 6 minus 2 is 4. 7 minus 15 is a negative 8. We simplify this. A positive divided by a negative is a negative, and 4 over 8 is 1/2. So the slope is negative 1/2. Let's do one more example. So if we slide this over to number 2, okay, again, let's label x1, y1, x2, y2. And then let's write our slope formula. M equals y2 minus y1 over x2 minus x1. Plug and chug. Cookbook City from here. y2 is 11 minus y1 is 9 over x2 is 17 minus, now be careful here, our x1 is negative, so he's special. We're going to put him in parentheses, and those parentheses just scream, hey, look at me, I'm negative, so we don't forget. And before we simplify, let's clean this up. 11 minus 9 over, subtracting a negative isn't really subtracting, is it? It's adding in disguise. So let's change it to an addition just to make life easier on ourselves. And now, 11 minus 9 is 2. 17 plus 17 is 34. And we can reduce this. 2 divided by 2 is 1. 34 divided by 2 is 17. Our slope is 1 over 17. Okay, if we look at the next page, we get into writing the equations of lines. And this particular set of examples, or set of problems, wants you to write the equation in slope-intercept form. And we're given 2 sets of points. Well, if we recall, slope-intercept form looks like y equals mx plus b, where m is the slope and b is the y-intercept. Well, we're given 2 points. Neither of the points is the y-intercept. We know that because neither of the x's are 0. And we're not given a slope. But we could calculate the slope because we just practiced doing that. So we could get the slope. And if you also recall, there's another equation of a line called the point slope equation. And that is y minus y1 equals m times x minus x1. In that particular equation, you need the slope m. So you need the slope m. And then you also need a point x1, y1. I'm not sure why this isn't ready. X1, Y1. There we go. Well, we have our points. If we label these X1, Y1, X2, Y2. We have our X1, Y1, and we can calculate our slope just like we did before. Using the slope formula, Y2 minus Y1 over X2 minus X1. Y2 is 5 minus Y1. Hey, look at me, I'm negative. I'm going to put them in parentheses. Over X2 is 5 minus 1. So if we clean this up, we get 5 plus 1, because subtracting a negative is really adding in disguise, over 5 minus 1. We get 6 over 4, which is 3 halves. So now we have an M, and we have an X1, Y1. So now we can use our point-slope equation. Our point-slope equation looks like y minus y1. Hey, look at me, I'm negative. I'm going to put them in parentheses. Equals m so that's 3 halves, parentheses x minus x1, which is 1. Okay? Well, we have our equation now, but it's not in slope-intercept form. But we can get it there with doing a little simplification. First, we can clean up our double negatives, which we know is really y plus 1 equals, and then we can distribute this 3 halves, making sure we give everybody some love. So we get 3 halves x minus 3 halves. Now, let's box the term we want to solve for, draw our street. So we know that the 1 doesn't make it inside the box, so we're going to subtract him. We're going to subtract 1 over here. You might be thinking, ooh, I have to subtract fractions? That's okay. Little review here. Negative 3 halves minus 1. We need a common denominator, so in this case would be 2. So minus 3 halves minus 2 over 2. Remember, when subtracting fractions, you keep the denominator the same and just subtract the numerator. So we get, once this is all done, that will cancel, and we get y equals 3 halves x minus 5 halves. And there is our slope y-intercept equation. Let's do another example. Let's jump down here to number 11. Okay? Again, the same situation. Okay? We have 2 points. We have x1, y1, x2, y2. Okay? I'm going to erase all this so we have some room. Okay? And I know I'm going to use my point-slope equation, y minus y1 equals m times x minus x1. And I need to get m, so that means I've got to use my slope equation, y2 minus y1, x2 minus x1. Plug and chug. It's calling for a y2, so I take 1 minus y1. Ooh, hey, look at me, I'm negative. So I'm going to put them in parentheses. Over, now it asks for x2, which is a negative 3, minus another negative 3. Hey, look at me, I'm negative. Okay, let's clean this up. Let's get rid of all those double negatives, because we know that's really addition. 1 plus 2 over negative 3 plus 3, right? And then we end up with 1 plus 2 is 3, and we have a negative 3 plus 3, which is 0. Got a little bit of an issue. 3 divided by 0, we have a slope that is undefined. We can't divide by 0. So if we think of slopes, the only way that we can get a slope that's undefined is if we have a line that goes straight up and down, which means this crosses the x-axis. And if you notice, our x's are the same. In fact, our x equals negative 3. Since our x's are the same, this would be the equation. We can't put it in slope-intercept form because our slope is undefined. Let's try one more example. Let's jump to number 13. Again, x1, y1, x2, y2. Let me calculate my slope, y2 minus y1, x2 minus x1. y2 is negative 5, minus y1 is 2, x2 is 1, minus 2. Negative 7 over negative 1, our slope is 7. So let's plug and chug. We're going to use our point slope equation. Y minus y1 is 2, m is 7, x minus x1 is 2. We have to distribute. Y minus 2 equals 7x minus 14. Box the term we're solving for, which means we add 2 to each side. That cancels. Y equals 7x minus 12. There's our equation of our line. Another way that we write an equation of a line is when we're given a graph. And the best way to do that is to write it in slope-intercept form, because there all you need is a slope and a y-intercept. And you can get both of those from looking at a graph. Our y-intercept, remember, is where the line crosses the y-axis. So in this case, our b is 4. And our slope, when we have a graph, we can use rise over run. So we want to know, how do we use rise and a run to get from point to point without cutting through any yards? We have to stay on the streets. So if we start at this point, we're going to go down 1, and we're going to run to the right 4. So remember, it's rise over run, so our slope is negative 1 over 4. So we plug that in for m, plug in our b, there's our equation of a line. We have 2 more. Here is a vertical line that goes through x equals negative 1, so that's the equation of our line. We have a horizontal line that goes to the y-axis at negative 1, so that would be y equals negative 1. Notice the slanted lines, they get the y equals mx plus b. The vertical and horizontal lines, those are our special cases. They get x equals negative 1. If it goes to the y-axis, it's a y equals. Good luck.